Hello, my name is Anuj Bhandari, and this is the poster presentation for my dissertation project of MSc Advanced Engineering Management. So the dissertation project is titled as Low Temperature Crack Resistance of Crumb Rubber Modified Hot Roll Asphalt. This research is inspired by common issue facing in colder climates such as UK. Due to the thermal stress, typical road in cold region do crack, creating high cost of maintenance and reduced service life. Traditionally, hot rolled asphalt lack sufficient flexibility at low temperatures. Pursuant to this research, the resistance to cracking of hot rolled asphalt was modified with crumb rubber from recycled tire to improve durability of the pavements. This approach supports both pavement performance and stability. So, looking at the aims and objective of my dissertation, the aim of the project is to critically analyze the low temperature crack resistance of the crumb rubber modified hot roll asphalt compared to conventional mixers of road uh, constructions in UK. Achieve the aim, the project focused on four key objectives to achieve how crumb rubber affect low temperature crack resistance. Second one is to review stiffness and ductility of the modified asphalt at a very low temperature. To explore the sustainability implication of using crumb rubbers. And finally, to provide recommendations for optimizing crumb rubber application in cold climate like UK. So talking about the hypothesis, the study is based on two hypotheses. So the first hypothesis, which is represented as S naught, there is elaborated as there is no significant differences in low temperature crack resistance between crumb rubber modified asphalt and conventional asphalt. And our second hypothesis is, which is represented by H1, crumb rubber modified asphalt enhances crack resistance, serviceability, and flexibility under cold weather conditions. This research addresses a practical challenge: low temperature cracking in hot rolled asphalt, particularly significant in United Kingdom. The thermal stresses requires asphalt modification in order to improve performance. Crumb rubber as a sustainable additive increases flexibility and crack resistance. It is used especially to alleviate the problem of low temperature cracking of roadways, which are important for colder climates such as the UK, but which are also more durable and eco-friendly. By exploring the use of crumb rubber from recycled tires, the study contributes to sustainability and durability in the road infrastructure. Through analysis of fracture resistance and stiffness, this research provides practical insights for both engineering and policy makers, for engineers and policy makers. So, moving forward towards our literature review, the literature confirms that asphalt modification improves durability and resistance to cracking. However, in cold climate, conventional asphalt becomes brittle and cracks due to freezing conditions. Crumb rubber derived from the recycled tire provides flexibility and resilience. Rubberized asphalt improves low temperature performance and sustainability as supported by the studies like Zin et al. 2023. However, there are also challenges such as higher cost issues in mixing and rubber dispersion as observed by Wang et al. 2022. Additionally, some studies shows conventional asphalt initially having higher crack resistance before modification. Theories such as fracture mechanics and viscoelasticity behavior helps explain the improvements in performance with rubber modifications. Importantly, there remains a gap in real-world validation and economic feasibility, which the study highlights as the area for future research. So, for the study of our paper, we use secondary quantitative research approach, relying on peer-reviewed data instead of conducting a new experiments. Only data extracted according to the strict inclusion criteria were used, focusing on crumb rubber modified hot rolled asphalt, comparison with conventional asphalts, cold climate conditions, especially like in UK roads, and both laboratory and field test data, which was which was referred from Rosa et al. 2022. Variable analyzed includes crack resistance to evaluate fracture resistance, stiffness modules to assess rigidity at low temperatures, and fatigue resistance, measuring endurance under repetitive load. This provides a sound method for evaluating low temperature performance of crumb rubber modified asphalt without doing new experiments. So from our study, we came to a few results and discussions. So talking about result and discussions, crumb rubber has shown significant improvement in low temperature fracture resistance. Durability and flexibility are improved, with the optimal rubber content being around 10 to 50%, as shown by Mozami. Moreover, environmental and sustainability benefits are also substantial. The use of crumb rubber reduces tire waste, supports the circular economy, and lower carbon emissions caused by asphalt productions. The use of crumb rubber modified asphalt helps crack resistance and flexibility of the mixes more than conventional mixes. But the challenge remains, such as a high cost and difficulties in mixing. Fracture mechanism and viscoelasticity theories explain these benefits, yet there remains research gaps on the durability seen in real-world conditions and the economic feasibility of widespread implementations. So, after my study, I came to a conclusion that the mechanical properties of hot roll asphalt are significantly enhanced by adding crumb rubber. The best performance was observed with rubber content between 10 to 20%. Recycling tires in this way supports environmental sustainability and long-term cost-saving goals, which outweighs initial investments. Crumb rubber asphalt is sustainable solution for improving road durability in UK. It is characterized by high initial cost but will deliver a lower future cost both in maintenance and positive environmental impacts. It is also found that overall crumb rubber modified hot roll asphalt appears promising and eco-friendly for road construction. Its durability is improved, its crack resistance, and will contribute towards solving sustainability problem associated with the roads in UK. So, talking about our ethical considerations, and the study maintained ethical standards for properly citing the references or data, avoiding plagiarism, and ensuring objectivity. Any potential conflict from industry-funded studies were cross-verified with independent sources to maintain the integrity of the paper or the study. And finally, I would like to sincerely thank my supervisor, Dr. Ghaffari, for his continuous support and guidance for my project. And I'm also grateful to my friends from university, Neeraj Boyo and Yogesh Sahu, for unwavering support throughout this project. And this much, finally, thank you very much for this opportunity and for this topic. Thank you.